So the first page, multiple choice, I was after iron. I know some people, a lot of people miss this first question. And if a lot of people miss one question, it probably won't get on your final exam. The follow-up best answer for this one was silicon. So, but I was really after when silicon fuses, it forms iron, and iron cannot fuse. Okay, it's like what we call an endothermic instead of an exothermic reaction. So actually B was what I was after. Question 2, which of these actually is kind of what I said is involved in sunspot cycle, but I kind of creates the sunspot cycle. And so I was after A, kind of that twister sort of situation with magnetic field lines and the sun rotating every 11 years, it kind of winds itself up. Question 3, after a supernova event. Now today in lecture we're going to talk about another type of supernova. The supernova we talked about so far was a massive star, more massive than 8 times the mass of our sun, blows itself up. So what can be left behind, and again we'll be talking about this more in Unit 4, is either a neutron star or a black hole. E is the best answer. Question 4, the core of the sun is, the best answer there is much hotter and much denser than its surface. So that's why nuclear fusion can occur in the core. Question 5. Without the use of binoculars or a telescope, the dimmest object with dark skies you can see is a magnitude +6, B. Question 6, when we talk about a planetary nebula, after the star ejects this material we call a planetary nebula, the thing itself, what used to be star, will retire into what we call a white dwarf. So A is the best answer there. 7, what happens when a star like the sun exhausts its hydrogen in its core? The best answer there is B, that its core will contract, but its outer layers will expand. So it moves into what we call the giant stage. Question 8. Maybe. Okay. Tunguska? That event is the event that happened a long time ago in Siberia. They think basically an asteroid, it's like a big sonic boom. It didn't really impact the Earth, but the best answer there is B. Question 9, on an HR diagram, where do you find the cool and luminous stars? And so remember, cool means that it's over there to the right, because those are your M-type stars, and luminous means it's up. So basically, you would be upper right, so A is the best answer there. 10, what are the layers of the sun's interior? And actually, yeah, it's cutting things off, isn't it? On my answer key, I put a little asterisk here, because when I look at your review sheet for this unit, I didn't, although we talked about the layers of the sun's atmosphere, we didn't talk about the internal layers of the sun. So this is one of the reasons that I took off 3 points. So the best answer there is C. We have the core, the radiation zone, and then the convection zone. Question 11, which of these describe an HR diagram? So the best answer there is E. We have surface temperature along the x-axis, the horizontal axis, and luminosity on the y, or the vertical axis. Question 12, what is a meteorite? That is actually a little bit of either an asteroid or meteoroid that has survived the Earth's atmosphere and fallen to the Earth's surface. So C is the best answer there. 13, on an HR diagram, where do you see the main sequence stars that would have the greatest mass? And we have this relationship between mass, the high mass and the low mass. So this would be upper left on that kind of that diagonal we call the main sequence stars. Question 14, of course our sun generates energy via nuclear fusion, D. Question 15, when we talk about Trojan asteroids, although more than just Jupiter has them, the Trojan asteroids we talked about will kind of escort Jupiter around in its orbit. So A is the best answer there. Compared to the star it evolved from, red giant is C, cooler and brighter. So again, if you think of an HR diagram, it kind of goes over here to the M, so kind of and up. So it's cooler and brighter. 17, which of these describe the stages for a low mass star? That would be a protostar, main sequence, red giant, and a retired white dwarf, which in today's lecture, we won't get really deep into chapter 14, but we'll talk about how white dwarfs actually come out of retirement, so it's kind of fun. Question 18, the fate of a brown dwarf. That would be, it's a failed star, right? So E, the best answer is it'll just cool down over time. Question 19, sunspots are anything dark on the sun's surface, like sunspots, are generally cooler, okay? And sunspots are kind of part of that first kind of what we call the surface of the sun. I call it surface of the sun, the photosphere. Question 20, why do those plasma tails of a comet, the tails of a comet, both the plasma tail and the dust tail, generally point away from the sun, and that's due to B, the sun's solar wind. Question 21, which of these correctly kind of relate luminosity, apparent brightness, and distance? And the best answer there is C. We say that the apparent brightness, what an object appears to be, actually has an inverse squared relationship with regard to luminosity. So C is the best answer there. On to the next page. So for 22, I was wanting you to go ahead and put those 7 spectral types from hottest to coolest, and that's O, be a fine guy, or girl, kiss me. So D is the best answer there. Question 23, LOL, why should you never look at the sun? And this one won't make it to your final either. I just cannot do this. And the reason is the best answer is C, that it'll make you blind. Question 24, asteroids, how do they differ from comets? And so B, the best answer there is that comets have both a rocky and icy part to them. Question 25, which of these would be furthest from the sun? And I do think this was on your Unit 2 exam. I'm not sure. So the best answer here is something in the Oort cloud is farther than Kuiper belt, and it's definitely farther than Pluto, asteroid belt, and Neptune. And this actually, remember in this section, it's possible to get 1 out of 2 points. So each one was worth 2 points. So 26, I was after coma as kind of that spherical region close to the nugget of a comet. As it gets close enough to the sun to begin vaporization. 27, this is the abrupt explosive end of a high mass star. That's again supernova, and we're going to call that type 2 here in today's lecture. Question 28, I was after white dwarf as those retired stars at the end of a low mass. Remember, low mass for us was 8 solar masses or less. But if it's 0.4 solar masses, it won't even be a red giant. It'll kind of just... So there's something kind of to that. Question 29, I was after turnoff point, as if you look at a cluster of stars that were all born about the same time, throw them on a scatter plot called an HR diagram, and kind of where the high mass stars have left the main sequence, then we can kind of gauge the age of the cluster of stars. I was after 30, I was after corona as the outermost layer of the sun's atmosphere. 31, the feature that's always present on the sun's surface. So if you put, for 31, if you put sunspots, this kind of throws it out. Sunspots are not always present. Sunspots are features of an active sun, and sun's activity changes. But sun granules is what I was after for 31. Question 32, gravitational equilibrium is that balance between the inward pull of gravity and the outward push of nuclear fusion that's going on in the sun's core. Question 33, I was after planetary nebula as, and I think I took, I'm not sure. There were a few of these, and I tried to be consistent, that actually you could get, if you didn't put planetary nebula or something else, seems like you might have gotten 1 out of 2 points. But I was after kind of that cocoon of material that kind of drifts away from the central star, which is ultimately a white dwarf. Question 34 was one where you could have gotten partial credit if you put comet or asteroid. Question 34 won't make it to my final exam either because there was too many, wasn't quite sure about it. But KBO stands for Kuiper belt objects, and as they're affectionately known, they are in the Kuiper belt. And sometimes I think people answer this by putting Eris and or Pluto, so that was fine too, for 1 point. But Kuiper belt objects is generally what those things are called. A star's luminosity, 35, is talking about the amount of energy that star is pumping out per second in watts. Question 36, Eris, and I don't know, maybe this will make it to the final exam, but is that controversial object that first was the 10th planet, and then it got demoted to become a white dwarf. It got demoted to become a dwarf planet, just like Pluto. Question 37, I was after eclipsing binaries. eclipsing, a pair of eclipsing binary stars, as we can tell that there's two there because of the dance they're doing, and the amount of light we get from that pair actually varies as one eclipses the other. 3 points apiece. And for 38, I just wanted you, I have them listed up there. You didn't have to describe them, although some of you did, which was cool. I wanted you to pick 2 of these 3 places we find asteroids. The belt asteroids, of course, between Mars and Jupiter. The Trojan asteroids, we said a minute ago, kind of escorting Jupiter around in its orbit. And the Apollo asteroids, the wild children. And for 39, again, these were each were 3 points apiece, and I tried to be consistent. But what I was really after was something like this with regard to what's going on in the sun's core. If you didn't exactly put this, one of the things I did need to see, and you could say hydrogen fuses to form helium, which is cool, but to complete that thought and get full credit, you need to say something about energy is also released. So, and actually energy in this thing is in the form of gamma rays. Question 40, I wanted you to say which have longer lives, the low mass or the high mass stars, and also you had to say why that was. And generally, pretty good job there. So of course, low mass stars have longer lives and high mass stars have greater fusing rates. Question 41, what is the minimum and maximum mass for a star? And like I talked about in lecture, I went with 0.08 solar masses is the lightest a star can be, because if it's any lighter than that, then it doesn't get the temperature and pressure it needs to have in the core for nuclear fusion to occur. And I went with 100 solar masses as the upper end, although I think your textbook does 150 solar masses. And on my slide, I say there's a star that's actually 300 solar masses. But if it gets too massive, then it basically just does not settle down. It's just crazy fusion rate. Question 42. Again, these were worth 3 points, and question 42 is one that some people got partial credit. Because what I was really after is those comet showers, these meteor showers we have is when the Earth is pushing through debris that was left by a comet. So something like that to get full credit. Question 34, you just had to list 2 of these 6, and I think there might even be a 7th one there out there hiding. But when we talk about an active sun, what features are we talking about the sun has? Sunspots, solar flares, prominences, and filaments are the same things. Coronal holes or coronal mass ejections, so 2 of those. Question 44, describe what we mean if we talk about a star being in its main sequence stage. So I was really after something about it is fusing hydrogen in its core to form helium. So that's kind of what I was after. And then the last one, when we talk about using an HR diagram to track the evolution or the life cycle of a star, what do we mean? And since this HR diagram has luminosity and temperature, we're watching the luminosity and temperature of a star change as the fusion is changing inside of it. Okay, so that was all that.